Hi everyone. Here we are with the second episode. Finally, after 4 very long years, this CoreXY printer started operating with the first prints. We can now put my old and trusted Prusa i3 clone aside. The 2019 Christmas holidays were needed to finish and give some dignity to this printer full of dust. The smooth bars of suitable length are now there, and being much longer they have been stopped with blocks twice as thick as the original design. On this occasion, the extruder block carriage was also slightly enlarged, just for a little more stability, and to make room for some news that we will see in a moment. Correctly fit and tighten the straps, some manual movement with your hands to check alignment and fix any abnormal friction. As anticipated in the previous video, I'll leave it here at the top right for those who have missed it. RGB LEDs have been introduced to the extruder block, that's why I had to enlarge it a bit. Design this ad hoc bracket, which can be equipped with 2 NeoPixel LED bars, for a total of 16 LEDs. They will then be placed in this way, remembering to dissolve and flatten these 4 turrets when the work is completed, so that they are firmly fixed. The bracket has been designed and built with special cable glands, in order to keep everything compact and in order. We then start by tinning the first bar to the second, with a 4-wire cable, ending by welding the 3 control and power wires to the first strip towards the electronic board that will control them. Extruder below, and special bracket above will complete everything, like this. We fasten the cables of the thermal probe end of the heating cartridge with some clamps from electricians. For convenience, a quick connector has been inserted to the extruder fan. It will facilitate the replacement of the fan when it ceases to function, because believe me, it will. A few patches of heat shrink tubing, and we also remove these cables. As already mentioned, the trolley that will house the extruder block has been enlarged, with a slight bevel at the internal corners. It will thus perfectly match the extruder together with its NeoPixel. The holes for the coupling have been revised. It will now be necessary to stop the printing at the right time and insert 7 cubic meters nuts inside it, before the printing ends. Another 7 nuts, together with the M3 screws, will be added after the printing is complete, as shown on the video. 4 screws will stop the extruder block to the trolley, while the cable clamp inserted in a corner will keep the whole bundle of cables in constant movement during printing. After completing the assembly of the extruder block, this is the result. There will now be room for a 40mm fan with a depth of 20mm instead of 10mm of the original design, thus ensuring a greater airflow. To complete and keep all the cables in order, I used a trivial 20mm diameter PVC tube, covering it with vinyl film and stopping it at the ends with special cable clamps. Brief view of the provisional press plan, from below. Since the print bed tends to fall down by gravity with the motors disconnected, or thought to draw and insert the special limit switch bracket to protect the trapezoidal axis coupler. The 2 screws with special rubber pads will stop the possible travel of the printing plate. While trying to keep the electronic and wiring part as tidy as possible, I made these clips for M3 screws, so as to stop the 2 flat cables of the display to the aluminum structure. A cable tie and some clips will keep the cables flat here, while the special 3D printed clips will fix the cables in the terminal part towards the display, all ready for some test print. Some other clamps to keep all the cables tidy. Fan for active dissipation ready, ignition. Perform a couple of test prints with more than satisfactory results. Nothing has yet been calibrated. It has been necessary to add an additional bracket that will house the amplifier for the part 100 temperature probe, together with a DC converter to correctly power the NeoPixel at a voltage of 5 volts. Last tip, these 3 screws, grazing the belt more than the others, have been replaced with 3 other M5 screws with a rounded and less bulky head. And while it seemed all was over, someone whispered in my head, 32 bits, 24 volts, BL touch, UPS, silence. And so, at the beginning of 2020, I decided to face the coronavirus panic with some modifications, and with the word some, I mean the complete replacement of all electronics. So let's see all the latest 2020 upgrades. BTT Tech Electronics, with respective QR code to useful links. Optional feat to pair a Raspberry Pi card. 3 pairs of power cables, just over half a meter long. Classic China-style USB cable. And of course the electronic board, BTT Tech GTR, version 1.0. New at the end of 2019. ARM 32-bit Cortex-M4 processor. Card with a lot of inputs, USB, microSD, Wi-Fi. Separate power supplies for motors, electronics, and heated bed. Slots for 6 drivers, configurable via software in mode, UART. Pinning to connect a possible Raspberry Pi card, in addition to the expansion slot of a second M5 card, with an additional 5 drivers. All well screen printed white on black. Already prepared for BL Touch, NeoPixel, UPS, auto-off module at the end of printing, etc. etc. What else to say? A more complete 3D printer card than this one does not currently exist. What more do you want? Ah, right, the little duck. To host this board, it was necessary to design an ad hoc bracket, flanked by a second bracket for extra accessories. Both brackets are designed to raise all the electronic boards and thus be able to carry out an electrical wiring below them, making it almost hidden. We find in the back all the housings for M3 nuts, for an easy installation of boards. These 2 card holder brackets I thought and designed to be equipped with 2 strips of connectors with 10 posts, 2 strips with 6 posts, and other 2 bars with 4 positions each. These connectors can be found on the network with the name. Ladies and gentlemen, the time has come to reveal my new complete setup for this LeXY CoreXY. First row of connectors. Second row of connectors. E3D amplifier for part 100 thermal probe. UPS for resuming printing in the event of a blackout. Power MOSFET to power heating plates of a certain power in a shorter time. BTT Tech GTR. Driver BTT Tech 2209, UART, with relative heat sinks. Wi-Fi module. 3.5-inch color touchscreen, with backlit knob. And the inevitable Ducklings mascot BTT Tech. The power source has also changed. The part will make this splendid modular power supply. Power supply equipped with 4 distinct slots, with fastened terminals. There will be 3 24-volt modules, while the 4th, the last one, will be a 12-volt for services. The 12-volt module will deliver up to 192 watts of power, while each 24-volt module will deliver 182.4 watts. This, although compact power supply, will in fact deliver 600 watts of total power. I think they can be enough. This LED strip, strictly black in color, with a density of 120 LEDs per meter, will accompany the NeoPixel lighting of the extruder. I do not have the measurement in lumens, but I assure you that the printer will be illuminated by day, with just over 1 meter of LEDs. Wall panels in black polyurethane foam, 3 mm thick, will close the printer using countersunk screws M3, and special washers in anodized aluminum in green color. T-nuts will secure this panel to the aluminum profiles of the printer. Once closed, the external and internal aspect will be this. Even the cat is curious to check the work in progress. Let's start wiring the electronics. Before starting, I will insert 5 cable ties in the lower part of this bracket, and 2 more on the next one. They will ultimately be used to secure all the power cables from the power supply to the electronic boards. Only once these clamps are inserted, we can proceed in fixing the various terminal blocks, first row with integrated nuts, while for the second row, in view because protruding from the aluminum plate, I will use black cap nuts. Next I will insert various clamps to secure all the wiring. Part 100 amplifier and UPS are almost ready. In the meantime, we completely eliminate the old printer electronics, free the aluminum sheet for cards, patch a few holes here and there, and make new ones to fix the two card holders to the aluminum sheet. Remember to insert the 16 cubic meters nuts before doing so. This is the first motherboard bracket, and this is the view at the back. As you can see, the first row of connectors protrudes from the 130mm wide aluminum plate. The cable ties you see on the screen are there, ready to house the power cables. Here too I used 4 black cap nuts to secure the first row of connectors. A little at a time, with a lot of patience, we get this result. We label all the various connectors with a template. In this way we will avoid confusion in the next and final phase of connection with the rest of the printer. The only two wirings that will not pass through the various terminal blocks will be the BL Touch, therefore it's 3+2 cables, and the 4+1 cables of the touchscreen display. These two extras will then be connected directly to the motherboard, in their dedicated pins. UPS, Part 100, MOSFET, all beautiful fixed to the aluminum sheet, boards raised by the appropriate turrets, just to hide the wiring and keep the final appearance as clean as possible. Also added the Wi-Fi module for wireless printer management, not yet entirely sure whether it will be used or not. As I said, all the power cables between the power supply and the electronic boards will pass through the edge of the aluminum plate, below the first row of connectors, secured by the 7 clamps provided. We will thus maintain a division between the power supply and the various outputs. And here are the 24-volt wired power supplies. Only the 12-volt wiring is missing for some fans in the printer lighting LED strip. Here we once again see all the terminal blocks lined up in a row, ready to neatly accommodate the wiring of the entire printer, because the order avoids problems, and the eye also wants its part. My printer will have to be functional, but also beautiful to the eye, otherwise it wouldn't be mine. And just because I'm not going to use the sensorless function on my TMC2209, I'm going to delete the central pin, like that. Once eliminated above all, we can install them in the first 4 slots, equipping them with the appropriate aluminum heat sinks provided by Big Tree Tech. In the meantime I have been given some other upgrades and extra accessories. Let's briefly see what it is. Set you brush yourself to clean the nozzle. Colored sheath for extruded aluminum bars. Various 30x30 and 40x15, 24 volts. BL Touch Genuine. Set to complete the extruder block, which at the moment I will not be able to install due to an incompatibility of measurements. Set of tips for cleaning nozzle. Thermal cartridges 24 volt, 50 watts of power, together with temperature probe part 100, originally 3D. USB extension cable, to extend the GTR card port to the edge of the printer. Various silicone socks for the E3D, V6 metal extruder. Toothed inserts with special groove for 1.75mm diameter filament. 8mm cap for trapezoidal screw, with a special mechanism that should prevent me from falling when the Z-axis motor is disconnected. Countersink for 3D printing. Kit to remove the nozzle and temperature without getting burned. Special 7mm insert, together with various nozzles of different sizes both in bronze, such as the original E3D, and in steel. Spring kit with 2 different compression levels, together with 2 roller kits with generous diameter for easy adjustment of the print bed, 4 in the M3 kit version, and 4 in the M4 kit version. Ending with M3 screws for 50mm, difficult to find. And that's all. Having chosen to switch from 12 to 24 volt electronics, we replace the extruder heating cartridge, and stagnates the heating bed in the 24 volt version. The 12 volt will in fact remain only to power the white LED strip, and the 30mm fan of the extruder until I replace it with a 24 volt, controlled by the electronics. We are in 2020, the time has come to implement auto bed leveling. We then mount the BL Touch, using a temporary bracket, and pass its cable inside the sleeve shirt, together with the other cables. The 40 by 20 mm 12-volt fan will also be replaced by a 24-volt fan, this time 40 by 15 mm. And with the extruder block and the part of various wiring on the machine, we are done. Then prepare the cable, clamp and ferrules of various sizes. We pass all the cables inside the PVC pipe, fixing them with clamps both above and below. In this way, we now proceed by connecting all the various cables coming from the printer to the appropriate terminal blocks. We would thus obtain a clean and tidy wiring. One last thing, as a precaution I printed two brackets that will support a 92 mm fan, just to keep the motherboard and its drivers cool 2209. You never know. To secure the fan to the new brackets, I will use these special anti-vibration rubbers. I think they come from some night fans purchased in the past. And also as regards the display, an upgrade with Bose could not be missing. 3.5-inch touchscreen, rigorously in color, and with LED backlit knob. With dimensions very similar to the previous LCD, I still had to completely redesign the display holder bracket, once again printed in double color, with this time also USB input, as well as the SD slot that we already knew. To close everything properly, we should first cut all these protruding welds, related to the encoder board, with a wire cutter. In this way we could close everything without problems. We removed the protective sticker from the baser, and closed the display. We retrieved the 50 cm USB extension cable and fix it, together with the 5-wire display cable, with a pair of cable ties. Externally to the printer we would have such a view, while the display cable we will finish fixing it in the appropriate clips seen in the last video. We insert the micro SD in the GTR card, and we carry out the first ignition. Well, the firmware has just been updated. Let's also try the external LED lighting. And place the active dissipation fan in its place. Now that the printer is operational, I finally have a printing area that I dreamed of before. With these 300 by 200 mm useful, I can finally print the two brackets, new, designed by me, that will support the printing plate. Impossible to print so far with my previous 3D printer, equipped with a 200 by 200 mm area. And here it is in operation, during its first 12 hours of work, with a slight imperfection in the middle of the print, due to the accidental loss of a bronze bearing from its seat of the extruder carriage. The fixing screw was probably left loose. Sin. This is the previous Z-axis print bed, not very stable due to the hastily printed arms. To make room for the upgrade of the trapezoidal bar, I had to enlarge the hole with a 12 mm drill bit to a depth of a few centimeters, thus having to draw and add a special bracket with two M4 nuts inside, fixed from below with two M4 screws. Also added the two new massive brackets. They weigh in fact 177 grams each, printed with 100% filling, and they're 340 mm in length. This is the spatial result of my new Z-axis trolley. Once the black and green sheaths are inserted into the aluminum bar, the end result is this. I am really satisfied with my creation. By these 40 mm clips to match the printer, we can now go to the calibration and final tests phase. I forgot, Z-axis carriage finished with kit knobs and M4 screws, together with blue springs, more rigid and suitable for this solid printing plate. Since this printer is a CoreXY, I changed the G code for the end of all my prints, bringing the plate to the maximum travel of the Z-axis, 170 mm in my case. With this print plate I modified. So the printing plate, with the printer off, will remain in the lower area, going up during the printing in the homing phase. Therefore I saw the need to add in this bracket a mechanical limit switch for the Zeta Max. Then made the fixing holes, inserted two cables for the normally closed contact, tinned the ends at the limit switch, and inserted in position, secured with 2 iron wires. It is connected to the card in the Zeta Max position. The Zeta Min already does the BL touch, so it remains empty in the card. In this way, when the platter drops too low by starting to squeeze the 2 protection rubbers, it will also impact on the max limit switch, which will stop the stroke at the Z motor. In Marlin, I have therefore enabled the reading of the limit switches at any time, and not only in the homing phase, so they will also have the safety function as well as positioning the zeros. For the printer closure, in addition to the 2 side panels already seen at the beginning of the video, I shaped this 3 mm thick PVC sheet to size and inserted it into the upper slots of the aluminum profile, obtaining a satisfactory, almost professional result. For the front, however, I printed hinges I modified ad hoc for this LeXY, which will hold 2 plexiglass doors, which will arrive in days. Being the micro SD slot of the motherboard not very accessible, I purchased an extension from micro SD to SD, designed an ad hoc 3D support, fixed with strong double-sided tape, and some M5 screws. This is the result. Now I can print using the motherboard slot, avoiding to use the display SD slot. In the meantime, the plexiglass has arrived, and I must say that in this coronavirus period, the quality from my usual trusted supplier has gone down. They will probably have many orders, because the products has several smears all over the place. They usually pay attention to this, not this time. The left side panel will also be in transparent plexiglass. In order to monitor the prints, we then surmount the right panel of the same dimensions already made previously, in order to detect the drilling points and instantly prepare the new plexiglass panel as well. We shape one of the 2 doors with the imprint of the display, fix the hinges with 10 mm M3 screws, and finally close the printer in all its sides. Soon I will study on how to also close the part above. For the moment it will remain open, waiting for some tests with ABS prints. We will see how it will behave with warping. And here are some shots of the finished printer. Stay connected and subscribe to the channel. Also press the bell to not miss the next episode. Let me know with a like if you liked the video, and do not hesitate to comment if you do not agree with any changes made, or if you would have done otherwise. Any advice is welcome. I'll wait for you at the next video.
Ciao.